Alright guys, just want to do a quick little overview on the scientific method. We've probably gone over this in class already, but this is just kind of an overview of the parts and the process of doing science using the scientific method. Okay, now the first question really is, why do we even use the scientific method? Why do we learn it? Why do we use it? Okay, why do we even have it? Well, to be honest, there's some pretty good reasons that we use the scientific method. It creates a number of things. First, it creates a natural progression and cycle to answer questions and to solve problems. The scientific method is actually quite intuitive. Intuitive means it makes sense, it comes naturally. Okay, so the scientific method we do all the time. We make observations. Well, look. We ask questions based on those observations. We make predictions. And in many cases, we even try to solve the problem by doing informal type of experiments, whether we know it or not. Okay, so we do the scientific method kind of naturally, but the scientific method, putting it on paper, kind of makes it more of a structured way of doing things. As natural as it is, we just want to write it down to make sure it's nice and structured. The second thing it creates is a template that every scientist can use and understand. So a template is just like a cookie cutter. Okay, you can have different kinds of cookie batter. You can have, is it batter or dough? Different kinds of cookie dough, different recipes. But if you use the same cookie cutter, it'll all be the same shape, all be the same size, and maybe even have the same texture. Who knows? But the scientific method is just like a cookie cutter. Okay, the science inside of it, like the ingredients, might be completely different. Okay, but we use this form as a way to structure our science so that other people can understand it. And it also helps for us when we read scientific investigations so that we understand what other scientists are doing too. So it creates a nice template for us to understand and for us to use ourselves. And the last thing it creates is a valid structure to ensure that data collected actually helps us answer the question or solve the problem. We want our data to tell the truth. And if we follow the steps of the scientific method clearly, then we're less at risk of collecting bad data. Because we can collect data from any sources in any way, but there is a bad way to collect data. And if we follow the scientific method, those kinks kind of get smoothed out, and we have a clear path on how to get data that tells us the truth. How to get data that's valid, okay, that tells the truth. And we'll talk more about that another time. So, what are the steps of the scientific method? Well, we've probably already talked about them, probably 3 or 4 years, whether it's 4th grade or 5th grade or 6th grade or 8th grade, whatever. We've heard them before, but the first step is always, what do I see? What do you notice, right? Observation, okay? What do I see? What do I notice? Let me move this out of the way. Oh, no. Okay. Okay, so observation. What do I see or notice? Okay. The next step, which is also covered, goodness gracious, Mumley, get it together, is question. What questions come to mind? Okay, so we make an observation about the world around us. The very next step is, what question might come to mind? Okay, we might have a question about our observation. Then the next step is a prediction, and in science we call these predictions, they're educated predictions, and we call them hypotheses or a hypothesis. Okay, and in middle school we write hypotheses in the form if, then, because. Okay, later in the video we'll talk about how to write them, but we use the format if, then, because. Okay, once we have our prediction, we run the experiment, right? The experiment is designed to collect data to help us to answer the question. So it could be an experiment in a lake where we're collecting samples. It could be an experiment with human subjects where we're feeding them something and watching what happens. It could be any number of things, but the experiment is where we do something and collect data and see what happened to help us answer the question. Okay, once we get the data, then we analyze it, we graph it, we find the averages or whatever we need to do, high points, low points. We do with whatever we need to do with the numbers so that it makes sense to us. So we analyze the data, and from that data we draw our conclusions. And the conclusion is always related to our hypothesis. Does the data prove the hypothesis correct? Or does the data actually reject the hypothesis and said, no, we were wrong? Okay, those are the two questions we got to ask ourselves. And if we reject the hypothesis, if our hypothesis is wrong, then we go back and we make a new hypothesis and we start the investigation over again. But if the hypothesis is confirmed, if we said, yeah, our hypothesis is right, then, hey, look, we have a scientific theory, okay? And we have data to back it up. Okay, now technically, the process of science is never over, and so either ourselves as a scientists or other scientists might want to confirm that we're correct. So I might want to confirm that I'm correct again, or another scientist might want to confirm that my theory is correct, and so they'll go back through and perform the experiment again to confirm. Okay, now no matter if the hypothesis is rejected or the hypothesis is confirmed, we always communicate our results. Okay, sometimes we communicate our results in lab write-ups in our interactive science notebooks. Sometimes we communicate our results in papers on a web page. Sometimes we communicate our results to community members. But the bottom line is the science that we discovered was not meant to be secret. Okay, it's meant to be shared. So those are the main parts of the scientific method. Now, next we're going to go into what are the parts of an experiment and how do we go about setting those up. So hang in there.